Welcome to this explainer. Today, we're going to dismantle a massive misconception about the AI boom. Everyone talks about how smart the software is getting or the raw capability of the latest models, right? Well, it turns out the global AI race isn't primarily constrained by that anymore. Instead, we are entering this fascinating, kind of gritty new macroeconomic reality where dirt, copper, power grids, and geopolitical chokepoints are the true elements dictating global power. It's honestly the ultimate irony. The most advanced digital technology in human history is completely, inextricably tethered to the physical world.
Okay, let's dive right into how we're going to break this down. First, we'll look at the physical AI constraint, then move to the delivery problem, the shift to intelligence as infrastructure, map out asymmetric geopolitical exposure, and finally, we'll examine constrained geopolitical coexistence.
Section 1. The physical AI constraint. Moving past model intelligence and software capabilities.
So, the absolutely crucial realization we need to grasp right off the bat is that the real bottleneck in the machine economy isn't compute scale. It's the physical inputs. Think of it like a layered system, what we call the machine economy stack. Intelligence sits way up at the very top, but its ability to actually execute, that depends entirely on the layers beneath it. Intelligence all by itself just isn't sufficient anymore. Real pricing power, the kind that dictates global markets, concentrates wherever constraints are the absolute hardest to resolve. It's control over the physical systems that scale intelligence that truly matters.
Now, what's really fascinating here is this concept of economic gravity. It literally pulls value downward toward those constrained physical layers. Up at layer 4, you have your logic and orchestration, the software models themselves. But the real economic gravity pulls all that value down into layer 2, which is energy and compute, and all the way down to layer 1, physical inputs and materials. Ultimately, whoever controls these bottom foundational layers fundamentally controls the entire stack.
Moving on to Section 2, the delivery problem, the transmission bottleneck in global power grids.
Energy must move before it can be used. I want you to just let the gravity of that physical constraint sink in for a second. We tend to think AI is limited by how much total energy a nation can generate. It's not. It is strictly limited by delivery. Every single mile of transmission introduces potential congestion, line losses, and grid instability. And that becomes a massive issue under the sustained stress of hyperscale AI workloads.
Look at China's grid architecture, for example. It is a textbook case of this geographic mismatch. Deep in its interior, there is abundant generation. We're talking hydro, solar, wind, you name it. But the actual demand, the heavy industry, the megacities, and that highly concentrated AI infrastructure, that all sits thousands of miles away on the eastern seaboard. Bridging that massive gap requires incredibly complex ultra-high voltage networks. So what happens? A massive energy capacity advantage gets turned into a deep structural vulnerability because it's entirely reliant on transmission stability.
Which brings us to Section 3, Intelligence as Infrastructure, the structural shift in the economics of AI.
And this brilliantly illustrates the shift we're seeing. Leading providers aren't treating AI like traditional consumer software anymore. It's becoming a utility. Actually, it's more like heavy infrastructure. We are moving away from the classic software model, flat pricing, per-user subscriptions, near-zero marginal costs where scale equals margin. Instead, the infrastructure model is taking over. Because these massive AI campuses now require hundreds of megawatts of continuous, uninterrupted power, AI inherits all the exact same characteristics as heavy industry. When demand spikes now, you don't just get more efficient code, you get higher prices or restricted access that is tied directly to energy availability.
So intelligence is now actively priced as constrained infrastructure. What this means in the real world is that the logic layer gets commoditized, while energy availability determines the marginal cost. Therefore, the systems, and frankly, the sovereign nations that are capable of sustaining these incredibly energy-dense compute environments, they're the ones gaining a durable, highly structural advantage. If you can't power it, you can't compete.
Section 4. Asymmetric Geopolitical Exposure. Mapping the strategic vulnerabilities of rival powers. When we step back and look at this impartially through a macroeconomic lens, the United States and China enter this machine economy with completely asymmetrical advantages. It's really quite striking. The U.S. holds massive downstream power. They've got domestic energy self-sufficiency, immense hyperscale compute concentration, and deep capital markets. China, on the other hand, faces vulnerabilities with imported energy and transmission across those vast distances we talked about. But they maintain overwhelming upstream leverage. They dominate rare earth refining, industrial processing, and foundational materials.
It's basically a perfect offset. Let's see how this builds out. Because of this massive asymmetry, no single sovereign system controls the entire stack from top to bottom. While the US dominates energy conversion and the compute software side, advanced semiconductor production remains highly concentrated externally. A huge majority of leading-edge capacity is located in Taiwan. Both of these superpowers rely deeply on global dependencies that they simply do not fully control.
To put this physical constraint into perspective, roughly 20%, that's how much of global oil and LNG flows transit the Strait of Hormuz. Because China relies so heavily on seaborne imported energy, even a partial disruption there is systemically significant to their entire machine economy. A strategic rival doesn't even need to completely close these choke points. Just sustaining a bit of instability disproportionately exposes systems that rely on long, vulnerable supply chains, immediately driving up costs and supply uncertainty.
Section number 5, Constrained Geopolitical Coexistence. The May 2026 Trump-Xi Summit Detente.
So, what is happening now? Well, recent signals from the May 2026 Trump-Xi Summit point to a really fascinating detente. We're seeing the potential for expanded Alaskan oil and LNG exports to China, exchanged for continued Chinese rare earth flows to the United States. Now, let's be clear, this is not a new era of cooperation driven by goodwill. Not at all. It is calculated strategic necessity to avoid a modern Thucydides trap. If the U.S. attempts to fully weaponize those energy choke points, it destroys the vital industrial inputs required for its own Western manufacturing. Conversely, if China restricts rare earths, it faces severe trade retaliation. They are completely locked in mutual dependency.
So the crucial point is this: escalation risks mutually assured economic disruption rather than clean strategic victory. That is the bottom line. The post-summit reality is a highly transactional, very constrained coexistence. Both rival powers are going to continue to compete aggressively, for sure, but they are forced to preserve the specific material and energy flows that the machine economy simply cannot survive without.
I want to leave you with a provocative thought here. As physical execution capacity is pushed to its absolute limits, can rival powers sustain this transactional coexistence without triggering the very constraints they are actively seeking to control? The next time you hear about a massive AI breakthrough, look past the code. Keep your eyes on the physical layers of the stack, the power grids, the shipping lanes, and the materials. Because at the end of the day, that is where the real power lies.